I am very excited today to be talking to one of my favorite people on the planet, Professor Jim Patrick, who's joining us from Sydney, Australia. It's really special to have you have some time with you today on International Cochlear Implant Day. So how are you doing?
Doing well, thank you. Thank you for staying up so late.
Yeah, no problem. No problem. To provide some background for those who may not know, so Professor Patrick started with Professor Graham Clark's team back 1975.
Yeah.
Is that right? At the University of Melbourne. So he was there, for the initial cochlear implant surgeries. We did a little tribute to Rod Saunders earlier in the week, who was the first multi-channel cochlear implant recipient. And then Jim was chosen to lead the commercial development team to develop the internal cochlear implant, as well as the wearable sound processor. So, and you would say huge undertaking if you think about, replicating something that has worked, in a laboratory setting to making it commercially available. And I think you had, correct me if I'm wrong, about 4 years of a timeline in which to do that?
Well, a couple of things. I actually was the first employee on this project in the Nucleus group, but David Money was the lead. He was the project lead. And there were just three of us at the beginning. And the CEO of the Nucleus group, Paul Traynor, gave us 12 months to develop the first system. Now, this was using government funds. The proof of concept in Melbourne had attracted government money. And so Paul was keen. We had the first patient implanted in 12 months' time. Well, it took us a little bit longer than that. It took us 13 months. But that was for the development of an implant, basically using pacemaker technology adapted to the cochlear implant use, and a laboratory processor still. So, which then moved very quickly to a wearable processor, like a binocular case processor. But that all, that took place very quickly.
That's so amazing to think about. And so you have dedicated your entire career to furthering the advancements of hearing, hearing health and cochlear implant recipients, and just, not only a brilliant scientist, but just a delightful human being. So, I've had the pleasure to know you for almost 20 years, which blows my mind as well. But during that time, we've had a lot of different discussions about, the progress and process that you followed. And, one of the things that I did not realize at the time, I was implanted back in 1997, my first implant. And so for a little show and tell, this is the sound processor that I had when I was initially implanted. So yes, you can see I would have to clip it to my belt and had this wire that would go like under my shirt and up to my ear. And I wore that for 4 years and honestly thought that that's what I would have for the rest of my life. And thankfully, thanks to the efforts of the team and to you, that we have this thing called upgrades, where I think I've now had 5 or 6 upgrades. And so my current external sound processor is just this little tiny thing. So tell us a little bit about like that process and how you had the vision to way back then to create something that would be able to allow us to have this thing called an upgrade.
Well, from the beginning, we wanted to make the implant very reliable, with the target being that it would last for the lifetime of the person who was the recipient, because explanting, reimplanting devices can be risky and cause damage and make them not function so well with the next model and so on. And so we wanted to be able to have an implant which would be upgradable with external upgrades rather than have the implant replaced as well. So also we knew at the time that integrated circuit technology was changing very fast, and so we anticipated that would be big improvements in sound coding that we could do using newer technology. And so it was really important that we could have the same implant and a series of explants with this upgraded sound processing. And that indeed is how it worked out. And as you saw, we moved from the belt-worn processor, and people hated the cables going up to the back of the head, to the BTE unit, and that was a major advance. And the latest one that we haven't shown is the Canso that I show here. Oops.
Yeah, there we go.
And this now has the microphones and the batteries and the coil all connected together and placed inside this one unit, which then just fits, held on by the magnet over the implant. And so this is the next improvement, if you will, in usability. And so, yes, this compatibility was a key requirement, indeed, of the implant from the early days. And it's worked very well. And so now, I mean, the outside technology is extraordinary. It does so much better. You know, the babies can expect to develop language normally, have all the normal opportunities of normal children, and so on. And of course, with the technology, you can do audio streaming from your telephone or from the TV, you make use of all the latest and greatest when it comes to the audio devices that are available today.
Absolutely. So again, it was just I think it was just so visionary. And I should mention, so not only with each upgrade has it gotten much smaller, as you can see, but it is improved hearing, because like you said, the technology, even from the microphone perspective and all of that. So with each upgrade, my hearing has improved, which is pretty cool, given that, most of us with hearing loss experience the decline as we age. And so it's been really cool to have these wonderful improvements. And like you said, the streaming, which I'm using right now, and I use all the time, which is just, fantastic. So that's cool.
I add one more thing. That is that the secret weapon, if you will, with the cochlear implant has been brain plasticity. And all of the expert physiologists said it couldn't possibly work because just a handful of electrodes, 20 odd electrodes that we have, compared to 30,000 nerve cells. I mean, how's that going to work? But luckily, we put the information in the right way, and the brain adapts to it. And so it can take people a couple of years, really, to get, as adults, to develop their best outcomes. But for the children, of course, the brain is very plastic and it adapts very fast. And so things happen very quickly with children, especially if they're implanted when they're very young. But adults can do it too. The brain's still plastic for adults. And so it has worked very well. Yeah. But the brain's the secret, really.
Yeah, that's a really good point. And I think that's an important part to bring up as well. We talked a little bit about this with Dr. Ruffin yesterday about sort of a little bit of the misconception that people have that once you have the cochlear implant surgery, friends and family and even those of us that being implanted think that, right, day one, I'm going to hear perfectly. And that's just not how it works. And like you just described, it does take the brain some time to adapt to hearing in this new manner. But it's amazing that, like you said, the plasticity of the brain and how it's able to understand this new way of hearing.
Well, and one of the quite remarkable things is that for people with single-sided deafness, and we just have FDA approval for this, the single-sided deafness, you can use a cochlear implant on one side and normal hearing on the other side, maybe with a hearing aid. And the brain can put them both together. Now that is quite remarkable. And the same, of course, with our hybrid implant, where we have some electrodes stimulating the high frequencies and acoustic input for the low frequencies. And again, the brain integrates it all. So it's quite amazing.
Yeah, wow. So thinking back over, your career, or maybe going back to the beginning, or is there other examples that you can think of things that you were really adamant about doing, either in the development process or that were going to aid for the future of what the technology could do?
Well, I think one example I would use is the ability of the implant to record activity coming from the nerves after you've stimulated them. This we call NRT, neural response telemetry, and there was some scientific work being done on this in some labs around the world back in the early 90s, and it seemed like a really useful thing to be able to incorporate. But it took us much longer than we anticipated, actually, to get the electronics figured out for it. And we had to have a few rounds of integrated circuit design and so on. And so we actually had a product introduction delay of around 3 years, I think, just to get that working. But now it means that with the NRT, when the device is implanted, the surgeon can actually check that it's functioning by stimulating and seeing the nerve response actually in the OR. And that's a pretty powerful tool, actually. So that's been very useful. So yeah, but it took us produced a big delay in the implant development because of the technology delays.
Okay, yeah. So sometimes the better thing to, slow things down to get a better result in the end, because yeah, for sure, having that peace of mind, as you say, for the surgeon in the operating room at the time of surgery, the audiologist, for the patient as well, to just like be able to say, yes, everything, all the electrodes, everything's working as it should be. Yeah, that's a remarkable thing to have.
Yeah, another thing that it lets you do, if the patient has residual hearing, you can actually measure the nerve responses to an acoustic input at the time when you're implanting the electrode. And so you can actually monitor the normal hearing response and know that everything is still good in your hearing preservation during the surgery. And that's been very handy.
Yeah, so many amazing things. So what do you see, having spent your career in this field, what do you see coming for the future?
Well, look, one ambition for a long time, for the last 25 years, has been to develop invisible hearing, where you actually have the microphone and whatever power source you need under the skin, so you don't need to wear even the Canso, right? You have to charge the batteries at some point. But invisible hearing with the totally, what we call the tiki for the research subjects, of which we've implanted a few in Australia back in the late 90s. That's the target. But I think it's still a long way away, because if you just imagine putting microphones under the skin, then they're going to pick up when you brush your hair, or even when you chew, the skin moves around, and so you make these loud noises that you don't want to hear. And so that encourages you to move the microphone to a place where the normal sound comes into the middle ear somehow. So there's lots of technology developments actually to get the same performance level that we've got with the external system that we have now. Now, in patients with these experimental units, they do very nicely because they've got an external processor as well. So they can use their invisible hearing mode, and which I think several of them still do anyway. Or if they really want to have a higher quality sound, say in a noisy environment, whatever, then they can put on their external processor. So you've got both options. It's kind of a first step forwards. But I guess the ultimate would be an invisible hearing, where everything's implanted under the skin and where you don't need a battery, where you can recover energy from the body to drive it. Unfortunately, the power level is a little bit high in an implant delivering electrical stimulation to give you hearing. But maybe, there'll be some clever technology to do energy recovery from the body in the future. So I guess that's what I imagine as being the ultimate, where you really can have effective replacement without needing to do anything else. You have the surgery, get everything set up, and away you go.
Wow. That would be interesting. So I remember, like I said, being implanted way back in 1997 with the initial side, thinking, oh, the technology is going to change so rapidly, like you described, that I'll just wait for the fully implantable. Well, that would have been missing out on almost 25 years. May will be 25 years.
And maybe another 25.
Yeah.
Because the other thing that's been happening, which has been very, very important in these COVID days, has been able to adjust things remotely, so to use internet connections. And again, you can get access to the nerve responses, and you can You need to fit, of course, each implant to suit the individual patient. So measuring responses and setting up the stimulation levels and so on, and doing that from a remote site, which means you haven't got to travel, means you can be, I guess, monitored periodically to check everything's working. If you've got a problem, you can get it checked out without having to drive maybe a long way to a clinic. So, the remote access has been a huge improvement, as I say, particularly in these COVID days.
Yeah, absolutely. So what would you say to someone who knows they have, hearing loss, but hasn't taken any action on it yet? What would you say to them?
Well, there's other studies, don't let me go the wrong way here, but studies looking at the impact of hearing loss, whether it's treated with a hearing aid or whether it's not treated, but at different levels of loss, and the aging population, and just showing that people with greater levels of hearing loss have got greater chances of dementia, cognitive decline, and so on. And they're still doing studies to demonstrate the benefit of treating the hearing loss. But there are a lot of, I think, quite persuasive hypotheses about why the hearing loss occurs. Biggest one being that if you're not hearing too well, then you have social withdrawal and you just stop trying to communicate with people. You don't go out anymore. You get isolated, and that just reduces the input to the brain. So with less activity in the brain, it just functions reduce over time. So treating hearing loss is really important. And it's just tragic that so many people who need a hearing aid aren't using it. Maybe they've got it sitting in a cupboard somewhere. And similarly, people whose hearing has deteriorated beyond 70 dB or so, hearing loss, who would really need an implant, just don't get one. And again, they don't do as well as they could with it if they had a cochlear implant. So we get to 5% or so of that population. And it's just terrible that people who would get a big boost in their quality of life don't get it.
Yeah. And then also to that quality of life factor, as you were describing the isolation, and I can, I go right back to when, my hearing was to the point where I was no longer able to talk on the phone. I mean, I was 21, I think, at the time, mm-hmm. and just withdrawing, didn't want to go anywhere, didn't want to interact, didn't want to. And I had no idea what was going to be, how that would possibly turn around for me. And I'm so incredibly grateful to you and the teams for bringing this amazing technology so that I had this second chance at life and this opportunities that I have had since. And so many of the hundreds of thousands of cochlear implant recipients that you've brought hearing to. So it's just such an amazing thing, and it's so special to have you joining us, like I said, on International Cochlear Implant Day. So I really appreciate your time. Do you have any parting thoughts or any last words you'd like to share?
Look, I think where we are now, it really is an outcome from the contributions of so many different people. You look at the multidisciplinary activities we've had to make it all happen. And we started with the surgeons and the engineers and the audiologists. In fact, now the fundraisers are really crucial. Getting reimbursement is well under control in many places. But for children, for example, I know in some countries, then the financial support stops when they get to their mid-20s. And so I know this is where your fund comes in. But I think when you look at the improvements to quality of life, this is really something that deserves continuing support throughout the life, from governments and so on, because it really is a life changer. And it's been amazing to meet people with implants. We haven't mentioned this before, but the idea of having collections of people, as in the celebrations in the US, is just fantastic. Go to a theme park and have a bunch of lectures and so on, and just meet all these people who are just so grateful at how their lives have been changed, and their families and their relatives and so on, right. All their friends, because they have an implant. And it's a very powerful thing, I think, inside the company. Now we have people stay a lot longer working for Cochlear, actually, because they see the impact of the work they do and
Yeah.
how it improves people's lives.
Yeah, absolutely.
So
Oh,
yeah.
sorry, go ahead.
I would just say to those who are watching, I mean, this is a wonderful organisation that's we're talking to. I mean, to Angela and the team she leads here, and they help people so much. And I would just encourage you to give her your support. Thanks.
Thank you so much for that. I really appreciate it. And you've been always just a great supporter and always encouraging. So I appreciate that so much. So thank you so much for joining us. Like I said, on this special day, and yeah, what an amazing thing that you've created and been able to give people that quality of life that you talked about. So thank you so much for all of your dedication and work to helping people just like me.
Thank you for those kind words, Angela. Great.